Hi folks, and welcome to another episode of Open Analysis Live. So today we're going to do a different take on deobfuscating JavaScript and Visual Basic Script, or VBScript. So we have another tutorial video where Sean walked through how to actually deobfuscate these scripts using the scripting language itself, where he walked through how to identify different sections in each script, how to identify how the scripts are actually able to run code within them, and how to basically step by step extract pieces of the script out and then reuse them. So I'll link to that video below if you guys are interested in taking a look at that technique. But today what we're going to do is we're going to look at using API hooks and a debugger to make the process a lot faster. So what we're going to do is first I'm going to give you an overview of how scripts are actually interpreted in Windows, because we need to understand the underlying architecture of what's going on. And then we're going to jump into actually deobfuscating a sample that was sent in by a subscriber, just a malicious JavaScript. And we're going to show you guys how quickly this can be done with a debugger. And then finally, I will show you a tool that Sean built that will do all of this automatically for you guys. So it'll be a little demo at the end of the video. So with that, let's pull up a diagram I have of how scripts are actually run in Windows. So here we can see, here's our script file. And the way it works is the script is actually sent to an executable called wscript.exe, which is in the Windows System 32 folder. And what that does is that will actually interpret the script, so JavaScript or VBScript. So when it receives one of these scripts, what it does is it interprets the script, and then anytime the script calls out to a Windows API, wscript will actually call out to that API itself. So here, what I have listed is two of the most common DLLs with the APIs in them that are used by malicious scripts to download payloads and execute the payloads. So on the download side, we have WS232, which is the internet or the socket connection DLL for Windows. And you can see here, there's a bunch of API calls which would be used to resolve host names, actually make connections to the host, and then retrieve data from the host. So that's what these APIs here are doing. And then of course in shell 32 DLL, shell execute pretty much speaks for itself. So that's actually the most common way for wscript to execute a command, is using shell execute. So if we look at this all together, we can see that we don't really need to know too much about what the script is actually doing if we just want to retrieve the URLs where it's downloading the payloads from and the commands that it's using to actually run the payloads, or if it's running some other commands on the system. So instead of actually looking at the script, what we can do is we can place breakpoints or hooks on each one of these APIs, and then we can just watch for the data that's sent to those APIs, so we can see if they're called, and if they are called, what's actually being sent to them. And that way we actually completely eliminate having to look at any of the scripts. And you can see that when we do this, you'll see that this is actually way faster than having to manually deobfuscate the script. Now the only drawback to this is that we are only as good as our hooks. So if the script is using other APIs that we have not hooked, then it's completely invisible to us and we won't capture that behavior. So we do have to be careful. We do have to run this in a sandbox or in a virtual machine, just in case we don't capture all of the API calls and the script gets away on us. So we do have to be careful on that. However, I can say that most scripts, these couple APIs will actually probably be enough to capture the behavior. And then once you have the URLs and the commands, you can just go and download those yourselves and take a look at them. So with that, let's take a look at the setup that we have here for our analysis. So we have a Windows 7 VM here, and on the Windows 7 VM, we have x32dbg, which is the 32-bit version of x64dbg, and we have our script here, which we've named bad.js. And so I'll just show you what bad.js looks like here. Here we go. So you can see it's kind of obfuscated. You can see there's an eval function here. I haven't beautified the script. And again, this technique, you don't need to know anything about the script at all. We don't even really care. So I just wanted to show you that it is some JavaScript there. So let's open up our debugger here. And remember that the JavaScript and wscript are interpreted by an exe called wscript, which is in the System32 folder. And so we're actually going to debug that executable in order to make this work. So let's open that up. I have it in recent files here. You can see it's Windows System32 wscript.exe. So we'll open that up. And then what we need to do is we need to change the command line parameters to that script. So let's go down here to change command line, and we need to pass it the path to this bad.js script. There we go. So this is what we're going to actually run. So we're going to run VBScript and we're going to pass it that bad.js as a command line parameter. So now what we need to do is we need to set breakpoints on the two DLL, so WS232 DLL and on shell32 DLL, because those DLLs are not loaded yet. So we can't actually set breakpoints on their APIs. What we're going to need to do is we're going to need to set a breakpoint on the DLL itself. And then once that DLL is loaded, we will know to set a breakpoint on the APIs. So what we're going to do is we're just going to right click add DLL breakpoint, and we're going to add one on ws2_32.dll, and we're going to add one on shell32.dll. There we go. So now we have two breakpoints on the DLLs, and we can just run, and hopefully we will actually break on one of those DLLs. So we've broke on the entry point here for VBScript. So let's just keep going. And now we have a breakpoint on shell32 DLL. So now we can go to the symbols, and we should see shell32 DLL here. So we click on it, and then down here in the search, we can search for shell execute. So here's shell execute exw. We'll just right click and toggle a breakpoint on it. Now here's the thing, we have to actually remove that other breakpoint that we have on shell32 DLL, because this breakpoint on the DLL is a breakpoint on any part of that DLL. So we're going to actually keep throwing that if we don't remove it. So let's just disable it for right now, and then we'll run. And now we have a breakpoint on shell execute exw. So we've actually hit that API that we put the breakpoint on. So let's go and check out and see what's actually being passed to shell execute. What is the script executing? Let's go to the CPU view, and here we have EIP is pointing at shell execute. So on the stack, we should see here are the arguments for shell execute. So what I'm going to do is bring up MSDN with shell execute ex, because the arguments are a little bit tricky. They actually pass a struct and they're not arguments. So we're going to have to parse that struct out. So let's pull that out. So here we have shell execute ex on MSDN, and we can see they actually pass this as an argument. There's only one argument, and it's actually this struct here called shell execute info. So let's click on the struct and we'll see what the definition is for it. Because again, we're interested in what the command parameters are that are being passed here. So we have the size, the mask, window handle, and then we have the verb and the file. So let's come down here and see what the verb and the file are. So the verb is the action that's going to be performed. So there's like edit, explore, find, etc., etc. And what we're most interested in though is the open, because that's actually what's used to execute files and commands. So the open verb and then the file for the open verb will actually be the command line parameters or the executable that is being executed by shell execute. So those are the two parameters that we're most interested in. And so let's just count them down. So 0, 1, 2, 3, and 4. So parameters 3 and 4 are what we're most interested on the stack here. So let's pop back to our Windows VM and let's look at the stack. So we have here is a pointer to the struct. So let's actually follow that in our dump here. Follow dword in dump. And then we have 0, 1, 2, 3, and 4. So here, this address here should be pointing to our verb. So let's take a look at that, follow that in the dump. And so here we can see we're following in a dump 2. We can see that it is indeed open. So this looks like they are going to execute something using shell execute. So let's go back to dump 1 and let's look at the file argument that's being passed, because that's the next one here. So let's just highlight it and follow the dword in dump. Okay. Oh, and here we go. So here we have the command that's actually being executed by shell execute. So we can see cmd/c start something. Oh, it looks like they're actually going to execute PowerShell here. Now here's a tip. You can see that there's these little dots in between the strings. And I've talked about this before. Usually when you see something like that, and if we look over here in the hex, we have the ASCII byte and then a 0 and then ASCII byte and then a null byte. When you see that, that means that it's a wide string. So there's kind of a cool thing you can do here. You can just right click and you can say text show as extended ASCII, which means wide, and then they'll actually turn this view into Unicode so you can read it. So we can actually now read the command that's being passed to shell execute from the script. Well, let's actually copy it out into Sublime and pretty it up so that we can read it a little bit easier. But we can already see they're probably going to execute some PowerShell. That's what it looks like. So let's copy that out now and we'll paste it into Sublime. Now we can see it's copied the offsets here. So let's pretty that out, but let's not wait for us to do that in the video. Let's just use some magic of editing. Okay, so here we go. Our PowerShell is nice and prettied up. So we can actually see indeed they are using command.exe to actually instantiate PowerShell. And if we look at this PowerShell script here, let's make it a bit bigger. Okay, so here we can see they're creating a path to the temp folder with the exe name 1079. Then they're using get request to download an exe from this URL right here. So something called pax18.exe. And then once they download it, they actually save the file to the path that they've created up here in the temp folder. And then once they're done all that, they use start process to actually execute the downloaded exe. So this PowerShell script is not obfuscated at all. It's very straightforward. So you have the C2 URL where they're downloading the exe from, and then you see how they're executing it. They're just using the start process command in PowerShell to execute it. So there we go. Super quick way to go from this obfuscated JavaScript here to a very clean execution of what they're doing with the payload, how they're downloading it, and what they're doing. So this script was a little bit different from most scripts in that it used two different scripting languages. The first was JavaScript, and then they used PowerShell. But the PowerShell was very easy to read here. We didn't have to do any deobfuscation. So you can see how quickly this API hooking technique can be used to deobfuscate JavaScripts without having to understand the scripting language yourself. Now, having shown you how fast that was with the debugger, let's clean this up, and then we will show you how to do it with the tool that Sean wrote. Okay, so let's open up a command shell here, and we've already downloaded the tool. The tool is called Frida WS Hook, and I will link to it in the description below the video. It's on our GitHub, and right now we've downloaded it to the desktop here. So let's just cd into the desktop and then cd into Frida WS Hook. Now, it's based on the Frida JavaScript hooking engine, and it's all open source. The cool thing about this tool is that if you guys want to add different hooks or remove hooks, it's pretty simple if you know JavaScript. You can just add or remove hooks as you see fit. So in this case, we have those few hooks that I showed you in the beginning slide set, and we will just run our bad.js script and see what the output is here. So we use Python to actually instantiate it, and it's called Frida WS Hook, and then we just pass it the path to these bad.js and run it. So here it's setting up the hooks, and then it runs it. So very quickly we can see the script is run and it's hooked shell execute, and it shows us the parameter that was sent to shell execute. So you can see the command was cmd.exe. The parameters are the same PowerShell script that I just showed you guys a minute ago. So here's the two different methods that you can use API hooking to very quickly deobfuscate or pull out important information from obfuscated JavaScripts and VBScripts. The cool thing about this is that you can also use the same technique with the debugger to quickly deobfuscate PowerShell scripts. Now you have to hook a different exe for that. You need to hook the PowerShell exe, but the same technique applies where you load that exe, you pass the PowerShell script as an argument, and then you actually set the hooks the same way that we showed you for this W script and run the PowerShell, and you will have the same result. So that's a quick way basically to avoid having to work through manually deobfuscating scripts, especially if you're not as familiar with the scripting languages, but you're pretty comfortable in the debugger or you're comfortable using command line tool like this. So just a quick video this week. Hopefully you guys can use this later on when you're dealing with malicious scripts that you need to analyze. Hopefully you found it interesting. And also thank you for everyone who is leaving comments with suggestions of techniques that we should cover or malware that we should analyze, and also some suggestions for some tools that we should take a look at. It's really awesome to engage with you guys. I know we're both learning a lot from the suggestions that you guys have. So thanks so much for that. If you guys aren't subscribed, remember to subscribe and turn on the little notification bell so that you get a notification when we post a new video. One new video every week. We'll try and keep this up for the year. And I guess with that, keep exposing the mechanics behind the malware and stay curious.